So the purpose of this video is to show the generator controls, and the way I'm going to do that is I need to start with selecting a patient so that I can make the controls active. And now you see that my control for the generator is active, and I will just explain what's all here. So in this case, I ordered, the patient was ordered a chest lateral, so that's normally done on the wall receptor. But it's possible to change that to the table or to a tabletop. I'll just leave it in the table right now. You can change that setting. So this is also set for a photo-timed exposure. I can adjust those settings. So I'm turning the lung field off, and now I'm turning the right lung field off. And I only have one cell selected right now, the center heart cell. So I can adjust that, or I can turn it off completely and go to a mass technique, a 2-point technique, where the kV is adjustable and the MAS is adjustable. So I'm just adjusting the kV up and kV down, and then the mass is the same. You adjust it up and down. Now, for some reason, if I needed to use a full manual technique or a 3-point technique, what I would do is select this button here, MAMS, and now you see that the MA cell and the MS cell, so the tube current and the time, are now active. So I adjust this, and then in the cell that's grayed out, the mass cell, it's indicating what the product is. So this could be useful if you're trying to reach a target MAS and you want to keep the filament current low, so that way you're doing it on the small focal spot, for example. So that's another option. Typically the clinicians would most likely use the photo-timed where possible, and then the mass wherever else. But there could be instances where you'd want a three-point technique, a full 3-point technique, and the software accommodates that. Here you can select the focal spot size, so small focal spot, large focal spot. This window here is the maximum integration window of the generator. So right now it's set up for 550 milliseconds, a little bit more than a half second. And typically you want to keep this as short as practically possible, because when the X-ray is off, you integrate noise. So in order to keep the signal to noise level as positive as possible, as favorable as possible, you'll rather keep this as short as practicable. So for example, if you know your exposure is 10 milliseconds for that particular technique, you can adjust this downwards. Okay, so the next thing is the photocells. We've talked about you have your left lung field, your center heart field, and your right lung field. This row here are your film screen pairs. Again, these are only active when your photo timing is selected. So if I go into mass mode, for example, you'll see that gets grayed out. So I'll go back into the photo time mode, and we can adjust this. So what this does is, if you're used to film, you recall that you had fast screen and film pairs and slower film screen pairs. So this software accommodates functions that are like that, and that can be useful if you're using some of the non-digital imaging applications. So here you have a dense step, a film density step, optical density step, which follows the Renard scale. So this is again legacy film technology. But if you have a doctor who likes to see something a little bit darker, then you go up, and it translates into 25% darker image following the Renard scale. So typically we set that to 0. There may be instances where you want to go up or you want to go down, depending on what the site requires. So this row here is a 5 selection patient thickness, and this is actually one of the features that gets used frequently. So using the normal process where an image gets driven by the APR selection from the RIS. Um, the technique would just typically needs to be looked at, and then this would be the next thing. If anything gets adjusted, it would typically be this. And in the case where you had a bariatric patient, you have your, in this case, a chest lateral. All of these parameters, all the other parameters look good. You have your correct photo timing cells active. You look in there and you see that the patient is a bariatric patient. Well, then you select this offset, and that will take your KV up to that range. And then if further adjustment is required, that's a possibility by using these arrows. But the concept is to make it as automated as possible. And then again, on the other extreme, if you have a PED, you would select this thin patient here, and then it'll drive the selection for that expected patient. So this selection here, 80 and 100, is a feature that AGFA has implemented to try to limit some of the tube track loading. So it really intended to extend the life of the tubes, is the simplest way to explain it. So using 80, what happens is it will not allow a full exposure per MA on the focal spot. So if your tube is rated for 320, it won't allow that. It'll allow it'll only allow the up to 80% of your 320 MA limited small focal spot. And then that, and the same thing is true on your large focal spot. And the benefit in that is the higher the MA, the more energy you put into that track, into the track on the anode, and it, in time it wears a track into it, and then in time it degrades. So this allows a simple way to stop the generator from immediately selecting the peaks of the tube file, and it extends the life of your tube. Now, in some cases, that might not be applicable. In some cases, you might want to say, okay, well, yes, it's true that I will get slightly shorter life out of this tube if I go to 100, but I really need to get that 320 MA out of the tube to get a shortest possible image in my small focal spot. So if that's the case, the user would just select 100 and it'll automatically compensate for that. So other things that are generator related and technique related that are here. So we talked about the wall and the table. And this here, this hand, is their freehand, their tabletop exposure, they call freehand exposure. So we have 3 receptors loaded on this. We have our table bucky, our wall bucky, and our tabletop. And if there was 2 panels selected, sorry, I'll show that again. It'll show panel 1 and panel 2. So in this case, I have 2 panels. This function here, I'll show in another video, it's the tube warm-up function. And that's something that's very nice because that's another way that AGFA has rolled in some technology that will extend the life of the tube, but also made it very accessible for a broad base of users, some of whom might not really be very familiar with how to warm up a tube adequately, or they might use multiple different ways of doing it. So AGFA has automated the process, which I think is to the site's benefit. So I'm going to close this image, or I'll make this exposure just to show the post technique parameters kind of coming up. Okay, so I've got my X-ray. I've got my X-ray processed. It looks good. So what I have now here is the post technique parameters. So because this was photo timed, you won't know ahead of time what the X-ray time on was. So it's displayed here. It was a 5 millisecond exposure. We used a 200 MA current. We had 1 mass in total. If you multiply this by this is what you come up with. If the site has a DAP chamber, which is a device that is present on the collimator that adjusts and measures the dose depending on the field that's collimated, this value here in centigrade per centimeter squared is displayed. So this is a good way to measure and track dose. It's done at as close to the source as possible, so over by the tube. But it's in fact, a lot of countries use this as the gold standard. And then the focal spot. So the focal spot shows you whether the small, which in this case is a 0.6, or a 1.2, which is a large, was used. So the clinician will immediately know that 1.2 equals large. It was a large focal spot that was used. So that is the high-level generator control explanation of the system. Oh, let me not be remiss in explaining one more thing. Over here, what we have is the HU. So what the HU stands for is heat units. And what that demonstrates to the user is how much heat they can put into the tube and complete their exposure. So in this case, 0%, the tube is cold. If they were at 95% and they had a bariatric patient, or they might want to think about, do I have enough joules left of heat that I can convert into heat to be able to make that exposure? So these are things that we've put into the system, that AGFA and Spellman have put into the system, and really sort of simplify and make things as easy as possible for the user.